Hey guys, welcome to your Wednesday math lesson. Before we start, I want to make a few announcements. One, I will be open for questions on Zoom today from 12 to 1:30. And then I'm going to take a little bit of a break and get some food and take some alone time. And then at 2 o'clock, we are going to have a class community circle. And this is for my homeroom. Hopefully, you should have had a community circle, and Miss Erling's homeroom had a community circle with her yesterday. Next week, you guys will have community circles at the same time, but Miss Erling and I will switch. So I will run the community circle for Miss Erling's homeroom, but it will still be on Tuesday. So you guys always come to community circles at the same time, but you'll see different people there depending on what week it is. They should be really fun. It's not going to be anything learning. I'm setting up a Kahoot that's about the fun facts that you guys shared with me. So you guys will get to learn a little bit about each other, have a good time, and maybe talk about some things you feel are important. Okay, so on to our math lesson today. Today we are continuing to think about equivalent expressions, and I promise next week we will do some real world math. I know we've been kind of stuck in whimsical math variable land for a while, and this will all be really useful as we move into real world math, but we will start some real world math next week. I'm super stoked for the problems we are doing there. Okay, so over the last 2 weeks, we have been investigating equivalent expressions, and through that investigations, we've uncovered a couple of patterns. And today, our goal is to put names to the patterns that we have uncovered. And so the first pattern we have uncovered is when you have an expression that might look like this. Okay. And if we drew this out, it would look like this. Okay. And on the math that we did on Monday, there were one really common mistake that was made. That people would be like, well, this is 1, 2, 3, 4, 5, 6, 7. So any other problem that gives me 7 tiles is equivalent. That is not exactly true. You have to remember that these tiles are different from each other. Some of these tiles are these big rectangle ones that are these X tiles. These ones are kind of that imaginary tile that could be 5 tiles and it could be 1 tile, depending on what X is. These tiles are always 1. These are our 1 tiles. So we can't actually group these tiles together. It's kind of like grouping apples and oranges. These are different than these. And so when we make an equivalent expression, we can only group together things that are the same. And so we can take these ones, we can group these together and turn this into 1, 2, 3, 4 times x. So if x was 2, each of these would be 2, so it'd be 2, 4, 6, 8. If x was 3, each of these would be 3, so it'd be 3, 6, 9, 12. But either way, we're multiplying x by 4. And we can see this up here because this is a 3x, and this one, though it just says x, is really a 1x, because 1 times x is always x. And so this is 1 plus 3x, giving us 4x. And then over here, we have 1 and then 2, which we can group together because they're all our 1 tiles, and we can group those together to be 3. And then remember, we have to bring down that plus sign because we didn't do anything. So we did this 2 and then these 2, and this plus was in the middle, so we got to bring these down. And this gives us an equivalent expression of, So we know that x plus 3x plus 1 plus 2 is 2 4x plus 3. And you should be taking notes on this. I'm starting to write with a marker because I'm trying to make this as easy to read as possible. But so maybe with your pen, this would only take up half the page. You don't need to write as big as I am. This is called combining like terms. Combining means to put together, like you combine lemon powder and water to make your lemonade. You combine ingredients. Like terms means terms that are alike, terms that are like each other. They look like each other, they are each other in the way that these y's are like each other and these one tiles are like each other. What you can't do here, so I'm going to flip the page. I'm going to show you what you can't do. Oops. I'm going to run out of this notebook real fast. This new thing. So what you can't do is if you have 2x plus 5 plus 1, which if we drew it out would be 2 of our x tiles plus 1, 2, 3, 4, 5 plus 1. What you can't do is combine these two things. See how these aren't alike? Like they're not the same thing. This does not turn into 7x plus 1, because if we drew out 7x plus 1, we'd get something that looks like this. And this is a 1 square. These are not the same. They are not the same, which means these are not equivalent. And I don't have place to write down that full sentence because I, for some reason, wrote this lower down on the page than I meant to. Not. So I'm just going to write not equivalent. Oh my god, I should probably learn how to spell that word. This is not how this works. Okay, so there's one other pattern that we kind of discovered over these last 2 weeks. I would recommend you flipping to a new paper now, even if you still have room on your paper, because we are now going to do, this one might take up a little space and I want it all on the same page for you, okay? Okay, so this is when we got something that looks like this. Look, I'm getting so much faster at noticing when this is frozen. I gotta do all my videos at midnight because no one texts me at midnight, guys. Okay, so this is when we have something that looks like this. This one's right. Okay, and if we were to draw this out, we would draw it out like this. Sometimes I wish I could speed up this camera, but then I realize you guys are following along, so this will take you just as long as it takes me to draw this out, because each of you should be drawing this out on your own piece of paper. But as I do this, guys, guess what I did this weekend? I learned how to make bread. I made a loaf of bread. My mom used to do that when I was a kid. I remember kneading bread with her. And so I called her and let her know, and she's very proud of me. Okay, one thing. 1, 2, 3, 4, 5. So remember we did, so the reason I'm doing this is because this is 1x, 2x, 3x, kind of like this, and then our 2x here. You know, these x bars are different lengths, but they're supposed to be all the same length. I'm just not. Okay. So this, and then we have 1, 2, 3, 4, 5 of them, because we did this first, and then we multiply that whole thing by 5. If we were to break this up into 2 groups, what we would get is that this group is 3x times 5. And I'm going to draw it that way because it will make the math a little bit easier, or a little bit more clear. And here, this section is 5 times 2. And if we want to apply the order of operations and make this even simpler, we can make both of these a simpler problem. Because these are all, this is 3 multiplication problems. It's 5 times 3 times x. And so because they're all multiplication problems, we can actually do this multiplication problem. But there's still that x, so we have to bring that x down. And then this one we can do as a multiplication problem, which is 10. And these two, because they're both next to each other, that's an addition problem. So what we've shown here, and oh my god, I ran out of space again. What we've shown here is that, so I'm going to turn this sideways and write it sideways because I want it all on the same page. If you have room on your page, keep writing it on your page. Normally, what we've shown is that 5 times 3x plus 2, we can take this 5 and we can distribute it from here and here, is equivalent to 15x plus 10. So we took this 5 and we multiplied it by this 3x. We took it and we multiplied it by that 2, and that gave us 15 plus 10. This is called the distributive property, or to distribute. We distributed this 5. So like distribute, it means to give to many things. Like I distributed the worksheets to the students. So I took the worksheets and I gave 1 to each student. I distributed the food onto everyone's plate. I took my food and I put a little bit on everyone's plate. Distribute, we distributed this 5 to the 3x, and then and also to that 2. And that's how we got 15x plus 10. So these are 2 different math moves we can make to find equivalent equations and to do what we call simplifying an equation. And so the math homework today is you are going to get an equation that looks like this. And you are going to have to figure out whether, first of all, are you going to use distribute? Are you going to distribute? Or are you going to combine like terms? That's your first step. And so for this one, because it has those parentheses, I kind of, like my brain is jumping straight to distribute. And so I'm thinking right away that I'm doing this. So I'm going to take, so 2x, because there's going to now be 2 x's. And I know that I would have drawn, if I would have drawn this out, I would have drawn 1, 2, 3, 4, and then I would have drawn 1, 2, 3, 4 again. And so that gives me 4 times 2, which is 8. And for this this homework, I'm actually not going to have you draw. I want you to start using those patterns that you saw as you drew things out and making yourself start to use that without math. And you are gonna have to write down what action did you take. And your options are that you either distributed or you combine like terms. So this one's distribute. And then I'll give you another problem. Maybe I'll give you 5x plus x plus 1. And you'll have to think, and here I'm going to do this and that, because I knew I would draw out 5 of those rectangles, and then here I would draw out 1 of those rectangles, and then I would draw out 1 little square. I know I can combine those rectangles together to give me 6 rectangles, 6 x tiles, plus 1. And so I know that these two are equivalent, and then I can say that this is equivalent, and I know the action I took was that I combined like terms. Okay, that's what your homework is today. There is one more step after that where you're looking at me solve a multiple step problem, and you're telling me what I did each step. And that is your homework for today. Good luck with your homework. Make sure to check in with me on Zoom if you have any questions. And hopefully I'll see, if you're in my homeroom, hopefully I'll see you in a community circle today at 2 o'clock. And next week I'll see Miss Erling's homeroom. Okay, see you later. Stay happy and healthy and have a great day. Bye.